Let me begin with the structural component design software solution, which is MIDAS Design Plus. MIDAS Design Plus is a very simple software solution. The user can provide the inputs. We can also get the analysis results imported in MIDAS Design Plus. Design Plus software as an output can provide us in the form of Excel sheets, in the form of Word report, and also can generate detailing and saved as a drawing. So these are the inputs and the outputs that can be done in MIDAS Design Plus program. The design standards available in Design Plus are Eurocodes, American Standard, and we also have the Aluminium Association for Aluminium Design. In this webinar, we will be looking at American Standard and the Aluminium Association. In the American standards, the design applications lie in the slab design, beam design, column, we have irregular column design as well, shear wall, combined shear wall, footing, basement walls, retaining walls, buttresses, staircases, corbel press brackets. These all are RC, these structural component designs available as per American standard. When it comes to steel design, we have beam column design, base plate design, staircase design, bolt connections, crane girders, purlins and web openings. When it comes to composite design, we have composite beam design, composite column design, and CFT column. Under the Eurocodes, we have incorporated as of now for beam, column, irregular column, shear wall, combined shear wall, footing design under the RC, and when it comes to steel, we have beam column, base plate design, and pole connection design. Under the aluminium design, we have beam and column design. So let us start now with the demonstration of how to use MIDAS Design Plus. We will be beginning with an irregular column design. So let me go to MIDAS Design Plus now. When we open MIDAS Design Plus, at the beginning itself, we can see all these members. All we need to do is take care of the design options from the workstream. Design Plus software solution can also import the analysis results from MIDAS Gen. For doing that, all we need to do is click on MIDAS link and click on the MIDAS Gen file which is already open, and then click on Connect. Further, you can select any type of the listed members. Select that member from MIDAS Gen program and simply click on Import. That particular column, beam, slab, or any of the members selected will get imported in MIDAS Design Plus. All you need to do is perform the design. Over here, we start with selection of the design code. When it comes to RC, since we are going to be performing irregular RC column design, let us see which all American standards are available. It is important to note that The ACI 318-14 is different. It's supposed to provide us results in inches and feet, and we have got ACI 318M-14, which provides us the output results in the form of metric system. So this is important. Other than that, we have got older standards as well for American codes. For getting the metric system result output, I'll be using ACI 318M14. We can fix the target ratios for design: flexural, compression, tension, shear and torsion, and others. Then when it comes to steel design, we can select the database from here: Aluminium Design, Reinforcement. Yes, so when it comes to RC design, we need to look over here for the reinforcement material. For FRP, we can select from here. From material, steel, reinforcement, we can select from here. The design load, uniform live load, this we can provide the forces basically by ourselves itself, so we can simply go ahead now and click on apply. After we are done with this, we can double click over here on the rebar code, and we can either change the rebar code from here and provide the range. The program will perform the design taking the minimum and the maximum steel reinforcement diameters available over here. We'll be using American Standard itself. So let us start with irregular column design. In MIDAS Design Plus, we call it as General Section Column. General section column, as in any irregular shaped column, can be designed in MIDAS Design Plus. I'll add a member. Alright, to begin with, we can basically start providing the information inputs, like over here, the material property. The concrete material property, let's say 30 megapascal. The main reinforcement is 500. Hoop bars, we'll keep it 400. Then the length 3.5 in the X and Y axis, that is strong and weak axis. Then further the Kx and Ky, these are the effective length factors which we can modify. From here we can enter directly, or we can click on this three dotted box and select the condition, support conditions. Likewise. And then we can go ahead, provide the information regarding splicing. If you do not want to splice the rebars, if 50% of splicing takes place, if 100%, and so on. Now the equivalent area for general section can be automatically updated after we put over here our section size or shape. Alright, so let's do that. Let us go ahead and import the Cad file. We can either draw directly using this section information from here, or we can directly import from a Cad file. So a drawing file can be imported by simply clicking on import. We can browse to the location wherever we have kept our section shape and open. So this is our irregular shape of column. Here we need two layers in the drawing file. One layer will be the out of the basically the periphery of our shape, and we can also import directly what is the rebar arrangement and that rebar arrangement will be in another set of layer. So I can select the section layer and click on OK. So after I click on OK, we have got our section shape successfully imported. We can click on update the size. The software will automatically create equivalent area for the general section. Next, we can provide our own reinforcement, or we can have the software provide us with the reinforcement arrangement. So keep it 0 and then we'll perform the design. Before we perform the design, of course, we need to provide the force inputs. So we go to the section 2, we provide the information for the cover. This is the clear cover. Then the hoop bar information. This we can provide. Then further, we can provide information for the tie bars, then the force and factors. So here we go, we start providing the actual force first. Alright, so that we will, let's take it as 3656. I've taken this load value from one of the gen files. Then further we can put this actual force for the shear check. Then the moment, this is going to be strong axis as in major axis moment, and this is the minor axis moment, mx and my. So I'll just provide 138 for our moment in x direction. We'll make it as biaxial by providing the same moment in the y direction. Then the shear forces, this one, so I'll make it as 75 and 65. So I'm just providing over here certain inputs, and after that the coefficients and the factors. So this is basically equivalent moment correction factor to take care of second order moments. Then further we can provide the beta d value. We can also provide over here the information regarding the load combinations, and the program will automatically use the most critical load combination for the column design. Alright, so we are done providing the entire information required for the irregular column design. Now all we need to do is either click on design or click on check. We click on design so that we get the reinforcements required for our section. And in case we want to check with our own reinforcements, then we can simply modify the reinforcement information and click on check. Now the design has been performed and we get the calculation results right over here. This is a simple summary provided which can help us understand if our column is passing or failing. And we can also see what are the demand capacity ratios. If we are not okay with it, we can definitely make changes and then perform the design or check. We can also get the detailed output from this report area that has been provided in the latest version. This is a summary result, and we can also get very quickly the detailed calculation of the design result. It checks with the slenderness ratio, magnified moments are calculated, checks with the minimum moment, design moments, checking the design parameters, moment capacities, provides with the PM interaction diagram, and performs shear capacity check. We can save this information in the form of Word file, or we can generate a complete input and output report from here. This report could be a detailed Word report or a text report. So if we generate a Word report, that will be generated in the Word file format directly, and that Word file will open up in front of us in a short period. It's going to take a little bit of time to generate this Word report. Alright, so the Word report is completed. And we get our output in this format. The inputs over here is the section shape, the forces, rebars, slenderness ratio, and all the checks that we saw. So this is how efficiently we can perform design of irregular shaped column and get an output in the form of Word file. We can also get the output in the form of Excel file by going to the member list and then clicking on Excel file. So that will give us an Excel file report. Right, so that was about the general column, and we can also get the drawing generated for the general column. So this is how MIDAS Design Plus can not only perform the design but also provide us with the detailing. This drawing that has been generated by Design Plus can be further saved into a .dwg file. So it's not just the design but the drawing as well as quantity. After performing design, we can create quantity and get the concrete volume per unit area of the section. Then the formwork area, we can get the rebars. This is in kilonewton, but we can modify the unit system to user defined and change the rebar result. Yeah, so here we have the main reinforcement and hoop reinforcement in tonnage. Alright, so this was about irregular column design in MIDAS Design Plus. Alright, so there was a question over here. The horizontal ties for vertical rebars. So basically the tie bars over here can be used. We can provide the rebars, diameter of the rebar, and get it designed by the software solution. So that is, yes, tie bars are also available for in the design result. MIDAS Gen has, yes, another question was there, do we not have irregular column design in MIDAS Gen program? Well, MIDAS Gen program can perform regular column design, but when it comes to irregular shape, we can use MIDAS Design Plus, or we have another solution, that is General Section Designer in MIDAS Gen. Alright, now I'll move ahead with the next design example, that is going to be for the composite column design. I can click over here on the member And then we'll go to the SRC. SRC is Steel Reinforced Concrete Design. And before we go to this, we can go to the SRC tree menu. And from the SRC tree menu, we can see over here, this is the code that we need to select for performing the design. We can double click and modify, since this is going to provide me results in kips and inches. So I change this into AISC LRFD 10M to provide the results in the form of metric system. And then I'll click on apply. Alright, let me change this to SI in system itself. And then further, we can go ahead and click on the column over here for Composite Column Design. Alright, so in the Composite Column Design, we'll click on Add here. We can provide any member name. We can apply this to the drawing and reports, or only drawing and reports and so on. These options are available. Then we can provide over here with the material properties, like for the concrete, the 30 megapascal, main rebars 500 and hoop rebars as 400. Then when it comes to the internal section property, what would be the material for the edge beam? So A36 itself, and for the studs A36. Now we can have our concrete column as a rectangular one, or we can have it circular. Let us look at rectangular. We can specify over here the width and the height of our concrete column. Alright, so that will be like width 500, let's take height as 600. And the length, let's change it as 5 meters. It's the same for X and Y. And the effective length factors. So these we can again modify or keep it as 1. In MIDAS Design Plus, we can have only edge type of steel section inside our concrete column. Then further, we can either use the database, select section property from the database, or we can provide our own dimensions. Let's use from the database. Then we need to provide the force information, axial, moment, shear, and so on. So I'll quickly provide over here the information of the design results. Shear as 50, that basically mx and moment in x direction is our major, my is minor, shear x, shear y for major and minor axis. Likewise, and then further we can provide equivalent moment correction factors and the beta d value. Then further we can provide the reinforcement arrangement and then ask the program to check, or we can leave it likewise and the program can provide us with the reinforcement as well as the section shape inside the concrete column. Hoop bar information also can be specified over here. Then the main rebar arrangements, like we would like it at the corners, shall it be auto-calculated or shall it be identically distributed, or at the corners with some as a distance. So that's one thing. Then next is checking the load transfer. If you want to check the load transfer, external force to steel only, then external force to concrete only, or external force to both materials concurrently. So that option we can ask the software to perform design checking with this option. Then the headed studs can be applied, providing with the spacing, the lengths, and the numbers. So after all this information, yes, and the spacing limit for the main bars, it's basically splicing. And after that, we can go ahead and perform the design. After we perform the design, we can check the summary design result over here. Requirements, the moment capacities, we can get the demand capacity ratios, shear capacities, and the strength of the studs as well. So this is a simple output. You can get the output from here as well, from this report. Detailed output or summary output. We can save in the Word file format just like we saw for irregular shaped column. So this was about the composite column steel reinforced column design in MIDAS Design Plus. Yes, and we can also generate Word detailed report for this type of design. And we can get it in the form of Excel sheet as well from the member list. One thing is that from the member list we can have as many number of columns to be designed, and we can at once perform the design for all the columns using this member list and get the output result in the form of Excel file. Alright, so that's about the concrete column design, composite column design in MIDAS Design Plus. I'll go now to the next type of design. When it comes to retrofitting, MIDAS Design Plus is equipped with Cfrp Strengthening. So we will be looking at Cfrp Strengthening in MIDAS Design Plus. Member, beam, reinforced beam. One thing is that we can have the analysis done of the entire structure in MIDAS Gen program, get that particular beam in concern in MIDAS Design Plus using MIDAS link, and then we can go ahead use that beam in the strengthening form to strengthen them. So in RC tree menu, we have got beam, and over there we can click on add. This is beam, and after we perform the design for this particular beam, for example, we have linked this software with MIDAS Gen already, so I'll open MIDAS Gen. Alright, so I select over here this particular beam, and then after, if the design has been performed for this particular beam, then it can be taken into MIDAS Gen program, but it's not going to get imported as such. Okay, oh, this one has been performed. Alright, so we have got our beam over here, and further we can provide information regarding the moments and the shear forces. And then we can take the design result in the member for the reinforced beam. Alright. So here we go. We are going to be now using this particular property. We'll provide the concrete material information 30 megapascal, main rebar 500 megapascal, stirrups is 400. Then the section width 400 by 600. The top cover 40 mm, and for the bottom cover we can use the top cover itself. Then the compression rebars if you want to consider or do not consider. The shape that is available, it's either rectangular or T-shape. So let's use T-shape, mostly use T-shape. We can specify the slab thickness connected. Let's make it 120. The effective width over here, this one we can calculate for the T-shape and inverted L-shape beam as well. Accordingly, when we hover over our mouse on the effective width, we get the information. It talks about how the effective width should be calculated. For a T-shaped beam, we need the effective width as 8 times the flange thickness of both sides plus the width of the flange. Or we can have the center to center distance of the slab. Then further we can also have span length of the beams upon divided by 4, and the minimum value among all the above three, all the previously mentioned ones. These can be used for the effective width calculation. And accordingly, inverted L-shaped beam effective length calculation, width calculation has been provided. In this design, we can also include the seismic provisions. Then further provide the rebar data information. So let's say there are 3 numbers of bars at the top, and at the bottom we have got some 5 numbers of bars, and we can have different bars at each layer or same rebars at top and bottom. This can be checked off, and we can have a different rebar diameter. Alright, and then further the stirrup arrangement, this one we can keep it to 200 mm. Then the skin rebars in case we require that for a deep beam. If it's evenly distributed, then the spacing limit, and we can also check with the cracked condition. Now let's provide with the forces. So we provide with separate dead load and live load moments, ultimate moments. So here we can provide information like for the dead load there is 50 kilonewton per meter, kilonewton meter. For live loads we have got a higher value of 100, let's say. This is just for example. And we have got moment, it's a negative moment overall, 120 kilonewton meter, and shear force of 120 kilonewton. We can also have lid combinations over here, or we can get the entire information from the RC beam. After we provide all that information, we'll go ahead over here in the reinforcement type. We have got FRP carbon, and we can have material selected from here, or we can click on user defined material and provide our own information. Let's say the thickness of our plate is 5 mm. We can have the fiber type as carbon, glass or aramid. All these types are available. The exposure condition, it's interior exposure itself, exterior exposure and aggressive environment. These options are available. Accordingly, the design will be performed. Then further, the property for our strengthening. Basically over here we can see that the first position over here, if we check this on, then we'll see our plate over here, and then when it comes to second position, it's on the sides, full length. When it goes for the third position, it's at the sides. We have to specify the length. Then 4 number is at the top location. Then number 5 is at the sides under the flange, and number 6 is at the top. So at these several locations we can provide the information. Alright, and then we can go ahead with the shear reinforcement. If we want two-sided bonds or U-wraps, we'll use the most common two-sided bond with a width and spacing. After we provide all this information, we can either perform design or we can perform check. After we perform check, we can see over here the design result. We can check over here with a detailed design information. It checks with the shear capacity for RC section only, the strengthening limit criteria, and the search for, okay, FRP is not existing in that cases. Then shear strength by FRP is checked. And the development length check is also done. So this is how we can get a detailed design report for our FRP strengthening that can be used for retrofitting purpose. So this was about the FRP or carbon type of strengthening in MIDAS Design Plus software solution. Alright, now let's look at the last type of design, that is Aluminium Design. In MIDAS Design Plus, we have got RC, steel reinforced concrete as well as Aluminium Design incorporated. For the Aluminium Design, we have Aluminium Association. So I'll go back to MIDAS Design Plus, and under the member, we can click over here, Aluminium. Alright, so this is general type, the second one that we see over here. One is the beam or column normal section property, and we have beam column general section, that is irregular shaped, can also be used over here. Let's check for the normal ones that are available in the database. Alright, so what we can do simply is provide the material information. Okay, the product, it's extrusions only. Then further the member type, if it is a beam or column. Then the shape, we can select from here. We can use the database from here. Then further we can also uncheck over here and provide our own section property information. Then further we can provide over here with the forces and factors. So when it comes to forces, you can provide over here, let's say for example, we have 125 kilonewton as actual force, and this is the major axis moment, strong axis moment. So let's say we have got 25 kilonewton meter. Then bending moment in the weak axis we can provide. Shear force we can provide over here. Let's say it is 50 kilonewton. Then further the calculation of combined stress ratios or CMX, CMY. Then lateral buckling coefficient can be provided, and we have got an M factor which can be calculated. If you hover over the M factor, then you can see how to calculate that factor. Alright, so after we provide this entire information, we can go at the section property. This has been automatically calculated from the information from the section shape. Then further we can provide the length of our column, that is the height of our column. So let's take the height of our column to be 3 meters. This is for the major axis, this is for minor axis. We'll keep it same. And this is the unbraced length. So this we can calculate or we can provide at any distance as required. Then we have effective length coefficient for buckling. So these ones we can provide manually, or we can click on this box to select from the support conditions. So after this we can go ahead and perform the design, or we can go ahead perform the check. If we perform the design, the program can suggest us with another section property. If you want to check with our own section property, then we can simply click on check. And then we can see from the design result over here, in short, if our particular section is failing for the design. So this is pretty fine. We can further reduce since we have got our demand capacity ratios very low. So if we perform the design, so the most least section property is taken, and accordingly we have got some better results than before. And here we go, we have got a detailed report at the sides ready with us just as we perform the design. So instead of like going to the design report generated by Word file format, you can check firstly the design result report from here. If it is satisfactory, then in the end like you can have a proper design report generated in the form of Word detail. So this is basically how we can design or check aluminium sections in MIDAS Design Plus. So until now we saw how to perform the design for irregular shaped column. We saw design for the CFRP, FRP design. We saw composite column design, and here we saw the aluminium column design. So all these things are available, as well as we can import the design results from MIDAS Gen software solution using MIDAS links for several other type of members. In short, MIDAS Design Plus has got some benefits that I would like to conclude in our webinar today. One thing is that in MIDAS Design Plus, components that cannot be designed in Gen can be designed over here, and those are in the form of steel, concrete, composite type of sections, as well as aluminium design. And these are as per the American as well as European standards. As a result, we can generate a detailed report of the design as well as check. This helps us to understand the software design and get a complete information on the design result. The drawings can be generated in MIDAS Design Plus and can be taken further into a .dwg file to be arranged with your other structural plans and so on. So that's drawings that can be generated in MIDAS Design Plus, and along with that, we can also get bill of material generated in MIDAS Design Plus. Last but not the least, it has got a link with MIDAS Gen that helps us to easily import the input values, and that reduces the human errors. So that is it about MIDAS Design Plus software solution. Thank you very much for attending our webinar. We have got more webinars coming up, so hope to see you again on the next webinars. So if you have any questions, please let me know. Alright, we have got few questions like, can we import the input from other programs like STAAD or ETABS? So that one, it's not possible. We can import the inputs from Gen itself, MIDAS Gen software. It is integrated with Gen. In case you have got the design results from other software solutions, you can just type in just like we did in today's webinar session. If you would like to know the price of the software, we would like to send it to you personally by email, or send everyone together by email along with the recording of this webinar. So whoever is interested, you can just let us know about your requirements, the number of licenses and so on. And yeah, that would help us to provide you with the appropriate information. Alright, the design using USD or ASD approach in Design Plus. So let me just go back to my Design Plus software. Alright, so here we have got in steel, or basically I would say we have got both the options. That is, we have got ASD as well as LRFD design. So both options are available. Okay, another example, can we do slab strengthening? Well, in MIDAS Design Plus, we have got for now beam and columns strengthening options available. Alright, we have got another question about what about flat slab design? Like, flat slab design is supported in MIDAS Gen itself. So you can model along with the entire structure, you can model the flat slab in MIDAS Gen and perform the design in MIDAS Gen itself. Alright, we have got many questions over here, and I would like to definitely write back to you and let you know about your queries with a proper solution for using MIDAS, where we can use MIDAS Design Plus and where we can use MIDAS Gen program. so that there will be a good clarity. Basically, for a small clarification, I would like to say that in MIDAS Gen program, whatever we model can be designed, but things that cannot be modeled or that are not usually modeled for our entire structure, for a full structure, those are designed in MIDAS Design Plus software solution. So that is the reason why we call Design Plus as a structural component design software solution. Alright, everyone, thank you so much for attending our webinar. We shall be ending our webinar session right now. If you have any more questions, you can simply write to us at globalsupport.midasuser.com, or you can write to me at nivedita@midasit.com. And if you would like to try MIDAS Design Plus software solution, you can go to our website, that is en.midasuser.com, and download straight away from there. You will be receiving an email regarding the licenses, and if there are any questions, you can on this as well, on the downloading part as well, you can write to us. Alright, so thank you very much. Hope to see you again for the next webinar session.